This video introduces you to Chur, Automature's test specification language. Chur is spreadsheet-based and can be specified using any document editor that supports XLS files. There are 5 worksheets in a Chur file, namely config. Here the configuration information is described. Macros. This worksheet allows Test Case Designer to declare short names called macros that can then be substituted in the test case description during execution. Test cases. This is where individual test cases are described. It is basically a sequence of test steps or molecules. Molecules. This is where the molecule and nested molecule collection of steps are defined. These molecules can then be called by test cases in the test case sheet. Prototypes. Support molecules and atoms prototyping. This will allow Zug to verify whether the invocation and the declarations of atoms and molecules are in sync. Config sheet contains configuration details like the location of atoms, database credentials, test suite name and role, etc. The macro sheet has 2 columns. The first column contains the name of the macros and the second column contains their corresponding values. The name of the macro is prefixed with a $sign. The values assigned to macros are stored as strings. The test cases sheet contains all the test cases. Each test case has a unique identifier which is specified in the test case ID field followed by its description. Property column is used to tell Zug how to execute the action or the test case. It can take auto or comment values. When set to auto, Zug executes the step. When set as comment, Zug simply ignores the step. Step can be specified for each action of a test case or a molecule, but not for a verification step. It should be a monotonically increasing number for each test case action. If 2 steps of a test case has the same number, then those 2 steps are executable concurrently. Some of these steps can be considered as initialization steps, a few others as the action steps, and the rest as cleanup steps. The initialization steps should be postfixed by an I, and the cleanup steps should be postfixed by C. This allows Zug to handle exceptions properly without the necessity to have semantic understanding of the actions. When no values are present, it simply executes the steps in a sequential manner. Next is the action field. A test case is a sequence of 1 or more actions, and each action may take as many arguments as necessary. The actions can be atoms or molecules. On the molecules sheet, a molecule is a collection of several steps which can be other molecules or atoms. An atom can be a program or script that can be independently executed in a command shell. A molecule has a name it can be referenced by, can be invoked by a test case or another molecule, accepts input arguments, and can also pass data back to the caller and can invoke another molecule. All action arguments should have action arg as the caption for the column header, starting from 1 and be incremental. For example, to have 3 arguments for the action, one can have 3 columns with column caption reading action arg _1, action arg _2, and action arg _3. The contents may be an actual value, a macro that would be substituted at compile time, or a context variable that would be substituted at execution time. Context variables are used to hold and pass information between test cases, molecules, and atoms. These are named containers that can be read and written to. While passing an argument from a test case to a molecule, only the value is passed. However, if the action happens to be an atom, the argument are passed as the formal name. Each action of a test case may consist of none, 1, or several verification methods, and each verification method may take several arguments as needed. When Zug encounters a failure status in verification, it automatically invokes the corresponding cleanup steps as declared under the step column. Just like action arg, verify arg are specified in incremental manner and can take actual value, a context variable, or a macro. The molecules sheet is similar to test case sheet, except the test case ID is replaced by molecule ID and is defined in exactly the same way as test case sheet. Prototypes. The purpose of prototype worksheet is to promote maintainability across versions of atoms and molecules. If interfaces change, then this would provide a quick way to flag incompatibilities. The idea of prototypes is to allow atom and molecule libraries to exist independently from the test case design sheets. The test case designer would include an external file containing the prototypes for atoms and molecules. The provider of the atoms and molecules would provide a prototype file that describes the interface specification corresponding to the release of atom-molecule library. In the next video of the series, you'll learn how to write a simple test case in Chur. Thank you for watching.